On November 24, 2024, a planned mission to Mars was discarded. Not for lack of money, not for lack of technology, not for lack of will, because the Earth had moved out of its proper place. And no one, no billionaire, no space agency, no supercomputer, could do anything about it. There is a rule that governs every human attempt to reach Mars. A rule that is not in NASA's statutes. That was not voted on by Congress. That was not drafted by any lawyer. It was written by physics 417 years ago. And today you will understand why even the largest private space company in the world can't break it. Welcome to today's video, where we will talk about the 26-month rule that even SpaceX can't break. The biggest obstacle to colonizing Mars is not the rocket. It is not the funding. It's not the training. It's the universe's calendar, and it doesn't negotiate. To understand the rule of 26 months, we first need to understand the dance. The Earth orbits the Sun in 365 days. Mars takes 687 days to make the same orbit. Different speeds, different distances, and a brutal consequence. The distance between the two planets varies drastically over time. At the closest point, called opposition, Mars can be about 56 million kilometers from Earth. At the farthest point, this distance reaches over 400 million kilometers. This means that a radio signal sent from Earth to Mars can take anywhere from 3 to 22 minutes to arrive. In an emergency, you send a distress message and wait up to 44 minutes for a response. But there is something more critical than distance. It's the position. It's not enough for the planets to be close. They need to be at the right angle, so that a spacecraft launched from Earth can reach Mars in an energetically viable way. And that angle only happens every 780 days, 26 months. This is what scientists call Mars's synodic period. In 1925, a German engineer named Walter Hohmann published a book called The Accessibility of Celestial Bodies. In that book, without computers, without modern telescopes, without satellites, he calculated the most efficient trajectory to travel between two planets. Today we call this the Hohmann transfer orbit. The idea is elegant in its brutality. Instead of going in a straight line, which would be absurdly expensive in fuel, the spacecraft traces half an ellipse. It departs from Earth toward the Sun, gains speed, and when it reaches the farthest point of that ellipse, Mars needs to be there, exactly there. If Mars is not in the right position, the mission won't launch. There is no detour. There is no alternative route that is equally efficient. How much does it cost to go outside the window? In technical terms, the delta V, the required change in velocity, increases non-linearly. A standard Hohmann transfer to Mars requires approximately 3.9 kilometers per second of delta V. Missions outside the optimal window may require 4.8 or more, which means exponentially more propellant. For a spacecraft the size of the Starship, which already requires 1,200 tons of propellant for the standard mission, any increase in this demand makes the scenario economically impossible. A standard Hohmann transfer takes around 259 days, about 8.5 months. Faster trajectory missions are possible, but they require much more fuel, with travel times ranging from 90 to 150 days, depending on the year and the available delta V. The optimal window lasts between 2 and 4 weeks. Then it closes, and it doesn't open again for another 26 months. Johannes Kepler described the laws governing this behavior in 1609 in the work Astronomia Nova, working with Tycho Brahe's observational data to understand the orbit of Mars. He didn't have a computer. He didn't have a telescope. It had only mathematics, patience, and genius. 417 years later, SpaceX engineers still use the same equations. Every major robotic mission to Mars in recent history has been launched within one of those 26-month windows. In July and August 2020, NASA launched Perseverance, the United Arab Emirates launched Hope, and China launched Tianwen-1, all within the same window. In 2022, a window with few significant launches, mainly orbital adjustments. In 2024, new window, missions planned to take advantage of the alignment. The next relevant window for crewed missions is in November and December of 2026, extending into January of 2027. SpaceX planned 5 uncrewed starships for this window. The goal? To test if the vehicle can land intact on Mars. In September 2024, SpaceX publicly announced plans for the uncrewed missions of 2026. In May 2025, Elon Musk gave an update. He estimated a 50% chance of being ready for that window. If it fails, the next one is in 2028. 50%. The largest private space company in the world, with over $10 billion invested in the Starship program, assessed its own chances as heads or tails. Not because the engineers are incompetent, because physics doesn't wait. But the 26-month rule is not the only obstacle that SpaceX faces. She is the final arbiter, the frontier that cannot be negotiated. Within this window, there are immense technical challenges to solve. The biggest challenge: refueling the Starship in orbit. A Starship bound for Mars needs approximately 1,200 tons of propellant for the mission. Each tanker, a version of the Starship dedicated to fuel transport, can transfer around 100 tons per trip. That means 12 tanker flights to refuel a single Starship. For 5 Starships destined for Mars in 2026, that amounts to 60 tanker flights. 60. And this number does not consider losses due to evaporation, the cryogenic boil-off. Liquid propellants at less than -180 degrees evaporate slowly in space. The longer the ship waits for refueling in orbit, the more propellant is lost, and more tankers are needed. In March 2024, SpaceX demonstrated for the first time a propellant transfer within the Starship itself, between 2 internal tanks of the same vehicle, moving at least 10 metric tons of liquid oxygen. The next step, planned for 2026, is the transfer between 2 Starships separated in orbit. This has never been done before by any agency or company. But what happens if this test fails in 2026? The window closes, and the next train to Mars only leaves in 2028. If this content opened your mind, subscribe now. The next episodes go further. Estimated duration, 90 seconds. There is something profoundly poetic about this story. Johannes Kepler was a German mathematician from the early 17th century. He worked with astronomical data collected by Tycho Brahe, a Danish astronomer who mapped the entire sky without a telescope, using only hand-built measuring instruments. Brahe assigned Kepler a specific task: to understand the orbit of Mars. It did not fit with the existing models. Kepler struggled for years. He tried to adjust the orbit to a perfect circle, as everyone believed to be the natural shape of an orbit. It didn't work. Brahe's data was too precise to be ignored. So Kepler had the courage to abandon the circle. He concluded that the orbits are ellipses, and he published this in 1609 in Astronomia Nova. This discovery, born from the problematic orbit of Mars, is exactly what determines the 26-month window. Kepler's ellipse is Homann's ellipse. They are the same physics, described with different instruments, separated by 316 years. Elon Musk has billions. Kepler had a quill and an inkwell, but both obey the same laws. What happens, in practice, when a window is missed? In operational terms, all crewed mission schedules are pushed back 2 years. Contracts with NASA, international partners, and suppliers need to be renegotiated. Ground support equipment remains idle. Engineers are being reassigned. Maintenance costs continue to accrue. SpaceX has invested more than $10 billion in the Starship program. Each 26-month delay represents a significant opportunity cost, although the exact numbers vary depending on the scope of the mission. But there is something more subtle and more important than the financial cost. SpaceX plans an exponential scale of missions: 5 Starships in 2026, 20 in 2028, 100 in 2031, 500 in 2033, with the final goal of 1 million people on Mars by 2050. Each missed window doesn't just delay the next mission, it delays the entire cadence. Each 26-month delay compresses the available margin for testing, learning, and correcting errors before crewed missions need to take place. The 26-month rule is not just a physical limitation. It is the metronome to which all Martian ambition is synchronized. It is tempting to frame the 26-month rule as a problem of SpaceX or Elon Musk. It isn't. NASA, the European Space Agency, the Chinese Space Agency, CNSA, the Japanese JAXA, they all plan their missions around the same windows. Every successful robotic mission to Mars in history was launched within these windows. Of the 56 missions sent to Mars throughout the entire history of space exploration, only 26 arrived successfully. More than half failed, lost probes, orbiters that missed insertion, modules that collided with the surface, and all those who tried outside the optimal window, by a difference of weeks, paid the price in extra fuel, longer routes, or impossible missions. Physics applies the same law to everyone. We live in an era of billionaires who launch rockets and promise cities on other planets, of engineers who build vehicles that land upright after flying into space, from a civilization that developed artificial intelligence, regenerative medicine, and fusion nuclear reactors in the lab. And yet, all this power, all this ingenuity, all this ambition, waits for the moment when Earth and Mars reach the right angle, the position described by Kepler in 1609, the trajectory calculated by Hohmann in 1925, 26 months, 780 days, a window of 2 to 4 weeks, then silence. There are laws that humans write, and there are laws that the universe wrote before any of us existed. The rule of 26 months is one of them, and the universe never answered a call from SpaceX. In the upcoming documentary, the cosmic radiation that awaits inside any spacecraft bound for Mars, and why the problem of protecting astronauts may be more difficult than getting there.